Hi, I'm Dr. Christopher Sutton, and welcome back to my Introduction to GIS video series. In this video, we will examine vector GIS data. Vector data represents geographic features as discrete geometric shapes, often referred to as geometric primitives. What are these shapes? They are points, lines, and polygons. Vector GIS data has two components. The first is geometry, which defines the shape and location of features. The second is attributes, which describe the characteristics of features. For example, a mountain could be represented as a point with attribute data of elevation. A road could be represented as a line with attribute data of traffic volume. And a country can be represented as a polygon with attribute data of population. The term vector is not unique to GIS, and you may have encountered it in other places. Generally, vectors are quantities that have magnitude and direction. In GIS, vectors are used to represent spatial features through points, lines, and polygons. Your first experience with vectors likely was with connect the dot drawings. You may have made a unicorn by drawing lines to connect points in the drawing. Similarly, we can construct a vector representation of Illinois by connecting points with known locations. The foundation of vector data is the vertex. A vertex is a single coordinate pair, which can be x and y or longitude and latitude, for example, that defines a position in geographic space. Vertices are the building blocks of vector data and can represent features as individual discrete points, as lines, and as polygons. Let's look at each of these. We'll begin with point features. In vector GIS data, a point is the simplest vector geometry, representing a single location in geographic space. The points in this image are the locations of headstones in a cemetery in Macomb, Illinois. A vector line feature is a sequence of connected vertices that form a path. In linear features, vertices are locations where the line changes direction. This map showing the streets of Macomb, Illinois is an example of line vector data. A polygon is a closed shape formed by a sequence of connected vertices. Polygons are comprised of three or more vertices, with the first and last vertices being in the same location to close off the shape. In this map, the polygons are counties in the state of Oregon. Let's look at this neighborhood and see how we might use points, lines, and polygons to represent features in this space. We have individual points, which in this instance are street lamps. We have lines, which are city streets, and we have polygons, which are the parcels of land. It is worth mentioning nodes. A node is a specific type of vertex that has a particular role in defining the structure and topology of lines and polygons. In vector GIS data, all nodes are vertices, but not all vertices are nodes. In linear features, nodes are vertices representing the start, end, or intersection of a line. A line can contain vertices that are not nodes, such as the location where the line changes direction. In polygon features, nodes are the first and last vertices of the boundary. In a polygon representing a lake, the shape is comprised of vertices defining its shape, and the first and last vertices are nodes. All vector GIS data is connected to an attribute table. An attribute table stores the non-spatial information about the points, lines, and polygons of vector GIS data. It essentially is a database table linked to the spatial data, where each row in the table corresponds to a feature and each column represents an attribute. An upcoming video will discuss attribute data in greater detail. In GIS, vector data formats are used to store and manage geographic features such as points, lines, and polygons, along with their associated attributes. Each format has its own structure, advantages, and limitations. Let's examine some of these formats, beginning with shapefiles. Shapefiles are widely used in GIS. They were developed by Esri and consist of multiple files that work together to store spatial and attribute data. If you were to examine a shapefile in a file manager program, you would see that all of the files contain the same name but use different file extensions. Each file type deals with a particular element related to the vector data. There are 3 mandatory files that must be part of a shapefile in order for it to load into GIS software. The first is the SHP file, which stores the geometry for each feature. The SHX file is an index file used for quick access to features. The third required file is a DBF file, which is the attribute table stored in DBase format. Optional files that are part of a shapefile include the PRJ file, which stores the coordinate reference system information, SBN and SBX files, which are spatial index files, and an XML file, which is a metadata file. Why did I mention the associated files of shapefiles? It's important to remember that a shapefile is a collection of files. If you have a shapefile that you wish to share with someone, you need to send them all of the associated files. If you share only the SHP file, the other person will not be able to open it up in the software. Another vector format is the feature class. A feature class is similar to a shapefile, but it is stored in a geodatabase. In addition to point, line, and polygon feature classes, there are annotation feature classes, text or labels stored as features, multi-point feature classes, multiple points stored as a single feature, and multi-patch feature classes, which store 3D representations like 3D buildings or terrain models. Vector data can be stored as GeoJSON files. GeoJSON is an open standard format based on JavaScript Object Notation, or JSON, for encoding geographic data structures. It supports points, lines, polygons, and multi-part geometries and is widely used in web mapping. GeoJSON files support complex geometries and attributes, but have limited support for advanced GIS functionality. KML files, which are keyhole markup language files, are XML-based files used for representing geographic data, particularly by Google Earth. They are ideal for Google Earth and web maps, but can require conversion for use in desktop GIS programs. GeoPackage files are an open data format using a single SQLite database file. They are widely used in GIS and can store both vector and raster data. You may also encounter OpenStreetMap files and CAD files in GIS. These need to be converted to other formats like feature classes or shapefiles prior to use in GIS software. What are the advantages of using vector data? First is precision and accuracy. Vector data represents geographic features using precise coordinate points, lines, and polygons. This allows for an extremely accurate representation of spatial features with the ability to capture exact boundaries, shapes, and locations of geographic elements like roads, property lines, or administrative boundaries. Vector GIS data files typically are smaller than raster data files because they store geographic features as mathematical equations and coordinates rather than storing pixel values for every single location. This means smaller file sizes and more efficient storage, especially for areas with complex geometries. Vector data allows for scalability and resolution independence. Unlike raster data, which will be discussed in the next video, vector data can be scaled up or down without losing quality or experiencing pixelation. You can zoom in or out of vector data, and the features will maintain their sharp, clean edges and geometric integrity. Vector data allows attribute information to be directly associated with each geographic feature. This makes data analysis and querying much more robust. Vector data supports topological relationships between spatial features. This means you can easily perform spatial analysis like determining adjacency, connectivity, overlap, and containment between different geographic features. And finally, vector GIS data can be easily transformed, rotated, projected, and manipulated using mathematical operations. While there are many advantages to vector GIS data, there are also disadvantages. Creating and editing vector data can be more complex and time-consuming compared to raster data. It requires specialized skills and software to accurately digitize and maintain vector features, often involving manual tracing and precise editing. While vector data is typically compact, processing and rendering large vector data sets can be computationally intensive. Complex vector layers with many attributes and intricate geometries might require significant processing power. Vector data is best used for discrete, well-defined geographic features, but it struggles to represent continuous phenomena like elevation, temperature gradients, or population density as effectively as raster data. Working with vector data typically requires more specialized GIS knowledge and technical skills compared to raster data. Understanding coordinate systems, topology, and complex spatial operations demands a higher level of expertise. High-quality, accurate vector datasets can be expensive to acquire, especially for large areas or detailed geographic features. Professional surveying, GPS measurements, and precise digitization contribute to the high costs. And finally, when working with vector data at different scales, generalization can be challenging. Maintaining the essential characteristics of geographic features while reducing complexity requires sophisticated algorithms. Vector data represents discrete geographical features using points, lines, and polygons. It provides high precision, attribute richness, and scalability. In the next video, we will examine raster GIS data.